Yeah, my name is Richard Morris. I'm a VP of Business Development at ACI Materials. I spent a lot of my career in this business, and before that I was in materials for printed circuit boards and flexible circuit boards, and I feel like my talk's going to sort of go full circle back to my earlier career of actually being able to build true circuit boards with print electronics. So a little bit about ACI Materials. We're a company based near Santa Barbara, California. We make inks, coatings, and adhesives that are extremely conductive, can be reflow soldered. Some of the materials stretch extremely well. Some of them are used for heaters. Some can be bent many times. Some shield, electrically EMI shield, and some are washable, and some survive re-entry from space. And the key to ACI's manufacturing is in their cavitation, high viscosity cavitation dispersion. And, you know, I've been in the coatings and inks business for a long time, and there are a lot of very traditional ways to manufacture coatings, three-roll milling, bead milling, etc. This is really a new way to disperse metallic and even pigments, carbon nanotubes, graphene very, very efficiently and evenly. If any of you know much about these particles, they often come agglomerated, and to really get the best performance out of them, you need to break up agglomerates and disperse them very, very evenly throughout the coating or the ink, the conductive ink or whatever, to get the best performance. And the way cavitation works, if you've ever seen a propeller on a speedboat, if you spin it too fast, you create vacuum bubbles, which then implode, and they start to erode the impeller. This is the same sort of theory behind cavitation, high viscosity cavitation, is we are forcing materials through and creating these small vacuum bubbles which create these very high energy jets that break agglomerates apart. And it really gives very high performance coatings, especially with metallic silver flakes and other things, as well as carbon nanotubes, as I said, graphene, and certain pigments and other particles that are difficult to disperse and stabilize. It makes a very stable coating, but most importantly, it gives you the best mechanical properties out of a coating, the best conductivity, and also very consistent quality, because we're not losing these. This is fully enclosed the way we manufacture, so it makes very consistent products with very high performance. In the conductive ink space, you have three different conductors. You have the traditional polymer thick film, which are percolation, where particles touch and you get the electrons jumping from particle to particle. But there is some resistance as you have resin in there for your adhesion to your substrate. You've then got nanomaterials, very tiny materials below 1 micron. They pack well, give you very good electrical performance, but you can't put enough resin, adhesion promotion materials in there to get great adhesion. So we work with semi-sinterable conductors. That's mixtures of particle sizes that actually sinter at low temperature to get very high conductivity. Now, really, I spent a lot of my time not just in materials, but in manufacturing. I was 10 years in roll-to-roll and sheet-fed manufacturing of print electronics. And, you know, there are various production methods, but still predominantly our industry for high, you know, medium, low, and high volume is sheet-fed screen printing. But we're also edging now with these materials into roll-to-roll screen and flexo printing for high definition. But what's most important is not printing at high speed, it's drying and performance at high speed with a wide process window for depositing very thin to very thick. So this is a look, and it's a little bit historical, at our Alchemy Ink series on top, curing at about 135 centigrade against other semi-sintering silver inks, against copper inks that require higher drying temperatures and some compression to get their conductivity. And it's really about getting that cure time down to use tunnel dryers and roll-to-roll dryers that are much shorter. So you really want a dwell time of 1 to 2 minutes.